All right. I've got every possible thing that I'm going to um, pull for the test. So it's two chapters: the chapter on the heart and chapter on the um, blood vessels. So in fact, I'm not going to use this question. So we'll skip right over this question. This will not be one of them. So first thing, and something we didn't have as a question on the quiz, was the conduction system. So a pretty straightforward question, right? This is the cardiac conduction system. Let someone in. Sometimes you guys know what it is. It's just that the question, maybe I don't use I don't know, maybe the words for the question. So maybe if I say, what is the cardiac conduction system? Like maybe that throws you off and you're like, oh, I don't know which one that is. Is that the one with the sodium and potassium going in and out? So this is the conduction system. And you just list it out. I mean, that's it, 1 through 5. Just kind of how it is there. That was not on your quiz, if I remember, but it could be on your exam too. So please know this, and it's just a list. Just listing it like you see it. So good for that one. Number 2. This is, if I ask it, I will be asking you, I'll probably want to know how an action potential is generated. Or I might just say something like, how is a cell depolarized and repolarized? I mean, I could say it that way too. So, and that would be getting to this question. This is another question I believe we did not put on the quiz, but it is possible to be on the exam. So 3 steps to this. Sodium rushes into the cell, that depolarizes it. Calcium trickles into the cell, that's the plateau. It kind of holds the depolarization or maintains it, as they wrote up here. Step 3, potassium exits the cell, that repolarizes the cell. I would like for you to know that depolarization is going to result in contraction. Depolarization is going to result in contraction. Repolarization is going to result in relaxation. Ideally. So, what are we on now? Second question? Yeah, so again, I could say, what causes depolarization and repolarization? Or I could say, explain how an action potential is generated. The key word here is like action potential, right? Because that's what this is all about. Action potential is like the spark. This one we had, the EKG, and what it represents. So that's one you had on your quiz. So again, well, I have it on the next page, don't I? Atrial depolarization, ventricular depolarization, ventricular repolarization. I don't think anyone would have problems with that question if it's on there, because y'all answered that correctly on the quiz. So that would be a repeat. Make sure you guys are there. Okay, you guys can hear me, right? All right, good. All right, I'm gonna go back. Difficult one. This was the number 3. If I were a betting man, I would bet that this would be, well, I'd be right because I'm the one that made the test. But if I were a betting man, I'd bet that this would be back on there because I keep talking about it. And I spent 3 slides on it, and I was saying that it was important. So that would be a safe assumption that I would throw something like this back on a test, right? If I have it all listed out, I will not want you to list it out. I want it to be a narrative. I like for you to well, I would break it up. I mean, you don't have to break it up like I broke it up as long as everything's there. But I mean, in worst case scenario, just break it up like this. So I have 3 parts: the atrial systole, ventricular systole, relaxation. So worst comes to worst, just break it up into those 3 parts, which is essentially the EKG, really. You know, P wave is atrial systole, QRX is implying ventricular systole, T wave is implying relaxation. So, atrial systole, just think about what's happening to the chambers. Are they contracting or are they relaxing? So you just start with the atria. Is the atria contracting or is it relaxing? Okay, well, it's called atrial systole. So atrial systole. Therefore, ventricular diastole. They're diastole. They're not going to be both contracting. Then you think about the valves. Okay, the ventricle is relaxed. What happens with a semilunar valve? Well, it's got to be closed. If it's relaxed, if the ventricle is relaxed, the semilunar valve's closed. AV valve's open, like that. And then, yeah, please include, again, the number, not so important. I don't care about the number. I just care, what is end diastolic volume? And that's being the amount of blood left in the ventricle after the atria contract. So at the end of atrial systole, how much blood's in the ventricle? So you just kind of explain that. So like if I were to write it out, I would say, okay, in atrial systole, blood has been filling from the vena cava, and eventually that forces open the AV valves, and the blood all drops in except for like around 25 mils. And then that's why we have systole, to push the rest of it in. The semilunar valves are going to be closed. The AV valves are open. The ventricles are relaxing, and the amount of blood that ends up in the ventricles after all of this is end diastolic volume. So that was kind of like a narrative of it. Then that part of it's done. Then you go on to ventricular systole. Okay, the ventricles are now contracting. So you think like, what's going on when the ventricles are contracting? Well, blood's going to get pushed out. So I'll start there. Blood gets pushed out. Now I got to think about what's happening with the valves. Like, okay, the blood's leaving through the semilunar valve. So the semilunar valves are going to open. The AV valves are definitely going to close. And if the ventricle is contracting, the atrium are relaxed. So I'll say atrial diastole. Then, yeah, the blood gets pushed out. And how much blood is left in the ventricle, we'll call that end systolic volume. And that's ventricular systole. So all I did was like, you take those 4 things that I wrote there and you just kind of explain it in your own words. I don't think I asked what stroke volume is. And this stroke volume here at the bottom, you don't need to put that. If you wanted to add it in, you could, but you don't have to. I mean, it's not, technically, it's not part of, ventricular systole. Then relaxation. That's the stage where all the chambers are in diastole or diastole. So the atrium, the ventricles, they're both relaxing. But at this time, it doesn't mean nothing's happening with the heart. At this time, blood's filling the atrium. So it's going to fill the atrium. Eventually, the semilunar valve's closed, so that closes because the ventricles are relaxed. So whenever the ventricles are relaxed, semilunar valves are going to be closed. AV valves, what are they doing? Well, they're closed for a short time, but as enough blood fills up, they're going to open up. And then the blood just drops in, most of the blood, not all of it, most of it drops into the ventricle, except for that last 25 mils. So I've already started saying a few things that I was saying back here at the beginning. How I was saying blood's filling and the AV valves pop open, the blood falls in. I was saying that stuff here. And I'm saying it here because it's a cycle. So I don't care if you don't talk about isovolumetric relaxation. I really don't care. I'm wondering if I should have even thrown that in. All I was saying was that there is a time during the relaxation period where all 4 valves are closed. But you can even skip that part if you want. So to summarize, all 4 chambers relaxed, so there's no contraction. Semilunar valves closed. The AV valves are closed, but then as soon as enough blood fill the atrium, they're going to open, and most of that blood's going to drop into the ventricle. That's it. That's relaxation. By the way, we call that when the AV valves open up and most of the blood just falls into the ventricle, call it rapid ventricular filling. That's what I've put up here. I said rapid ventricular filling just occurred. I'm talking about the end of relaxation. So that's how I did it. Again, if you do it the way that a book has it, that's also fine. I just want to see that you have the events. I just want all the events there. It doesn't have to be like my way, as long as you're discussing the events that happen. And then just remember it this way in your head first before you start the question. Atrium contract, ventricles contract, everything relaxes. Atrium contract, ventricles contract, everything relaxes. That's all this is. Atrium contract, atrial systole. Ventricles contract, ventricular systole. Everything relaxes, relaxation. And you just go to each one of those parts and talk about what happens. So, any questions on cardiac cycle? stroke volume. We had that question on the quiz. So I'll just leave it. I mean, most of you got it. So it might end up again on the exam. And then the last question that's on here that's similar to another question we have. Here it's control of heart rate. But after this slide, when we talk about blood vessels, it'll be the control of blood pressure. And the questions are a little bit similar. If we were to talk about how they're the same, well, this whole neurological side's the same. The only difference is what's the effector? Like what's happening at the end of it? You're speeding up heart rate. On the other, with blood pressure, you are causing vasoconstriction. And there is another nerve involved in it, but I mean, it's like the same idea. You have baroreceptors, you have chemoreceptors, and hormones, epinephrine. Well, now we could say something a little bit more about this because epinephrine speeds heart rate. Technically, I shouldn't put norepinephrine here. I should save this for control of blood pressure because norepinephrine increases contractility. So that would be a blood pressure thing. But anyway, you could leave it like this if you want. Sodium and potassium, slow heart rate. Calcium raises or speeds and strengthens heart rate. So that's from the quiz. Now we're finally getting on the arteries. So all of those were heart questions that might go back up. If I didn't ask it on the quiz, there is a good chance it will end up on the exam. That's just like a natural inclination. But there's 10 questions on the there's 10 questions on 2, 3.
You're freezing up.
4, 5. I got 6 possible questions here. So if I were going half and half, then I wouldn't be asking one of those. So did you have a question?
You froze up.
I did.
Yeah.
For a long time?
No, just on that slide.
Probably wasn't anything important. On this slide that I'm on now?
Yes.
All right. Trying to put my phone somewhere where I'll get like a good signal. All right. Okay, so arteries. Yes, this one's a possible question. How will I ask it? I'll say, maybe I could say, I don't know. I don't know how I'm going to ask this. What's the difference between, what are the other names for elastic and muscular arteries? And explain their differences. I mean, I guess so. So instead of elastic, you would put conducting, and the other name for muscular is distributing. What are their differences? The elastic are found closer to the heart, and they have more elastic in them. That's it. The muscular are found further away from the heart, and they have more muscle in them. More muscle in the tunica media. Kind of what I wrote here. That should be like an easy question. Three types of capillaries. Definitely another possible question. So this is the second question from blood vessels. What are the, did I put it? No. So what are the three, name the three types of capillaries. And so they're right here, A, B, and C. Continuous, fenestrated, sinusoid. And give like a quick explanation about each one, or just say like a sentence about it. Continuous capillaries have small intercellular clefts. And that's all that there really is in those. Fenestrated capillaries have a little bit larger intercellular clefts, and they have fenestrations, also known as pores. Right, so they have those pores in it. The sinusoid, they have very large, extremely large, go Donald Trump on that one. Intercellular clefts and huge fenestrations. And that would be an explanation of each of them. Did I write this on another page? I did. What are the pressures driving filtration and reabsorption? So that was 1, 2. This is question 3. Third question. What are the pressures driving filtration and reabsorption? It's here. I'm going to want you to explain it, which is essentially what I have, but you're putting it like in sentence form, right? And so I don't want you writing IFOP pull. Like some people do that. They'll just be IFOP pull, BHP push. No, that doesn't mean you know anything. That just means you associated words together. So, I mean, it's not wrong, but blood hydrostatic pressure is the pressure from your heart beating. You don't have to say pressure generated from ventricular contraction. You could say it in some other way. It's just your pressurized blood from your heart beating. That's blood hydrostatic pressure. And then interstitial fluid osmotic pressure. You could just say when there's more albumin in the interstitial fluid. That answers it. When there's more, okay, we'll really answer it. When there's more albumin in the interstitial fluid, it attracts the water, or it pulls the water out, however you want to say it. And then blood colloid osmotic pressure is when there's more albumin in the blood. That pulls the water in. So it's albumin here that you really should mention. And you should know what filtration and reabsorption are, right? Filtration is something leaving a capillary. Reabsorption is something going back into a capillary. Have I been breaking up more? Okay.
No, not too bad. Maybe once.
I'm wondering if I should switch it. No, I'll just leave it. Oh.
I'm sorry, what was the question for how are you going to word it? I started writing, but I didn't get it. You were saying
What are the sure. What are the pressures driving filtration and reabsorption?
Okay, thank you.
Sure. So 1, 2, 3, 4. Question 4. I want to know what a like a blood pressure, a normal blood pressure. When someone sticks the cuff on your arm and squeeze the ball, or actually hook it up to the machine, and it's squeezing on your hand, on your arm, what is happening? Like, what do the numbers mean? I don't care about 120 over 80. I mean, I know you all know that that's a number, right? So I could care less about that. I want to know, what do those numbers mean? And don't just say, and I don't want you to write just systolic and diastolic. What is systolic? I guess this is what it's really getting at. What does systolic and what does diastolic mean when you take a blood pressure? And I've already written it. If you write it just like that, then it's correct. There's not a whole lot of ways to say it. I mean, that's what it is. The pressure on your artery wall during each contraction of the ventricle. And then the other one is the pressure on the arterial wall when your ventricles are relaxing. Or if you wanted to get fancy, you could say ventricular systole and ventricular diastole. Because that is what the words mean. So, like I was saying, I'm not going to ask you mean arterial pressure. I won't. What are the factors contributing to resistance? That's how I would ask this question.
Shit, what did I just say?
So that's it. What are the factors contributing to resistance? I want you to explain it, right? I don't, and by explaining it, it means, all right, one of the factors is size of lumen. All right, what does that mean? What do you mean by size of lumen? So if it's big, then that is like more resistance, so then you will say, as the lumen gets smaller, resistance goes higher. That's it. Or you could say the opposite. As the lumen gets larger, resistance goes down. Either way. But you're giving a short explanation that you understand what it means. And length of vessels. What do you mean by length of vessels? Well, the more vessels we have, the more resistance. I know it's like a simple thing, but I just want you to know. I want to know what length of vessels are. Like, what do I mean by that? I don't care about 250 miles of that was just a FYI thing. I was just trying to demonstrate that it's possible to have more blood vessels. But the point is, when you have more blood vessels, you have more resistance. And then viscosity means like thickness. So as the blood is more viscous, or you could say as blood viscosity goes up, the resistance is going to go up. So that would be like an explanation. You can just like list each one: size of lumen, length of vessels, blood viscosity, and then just put after it, you could say, what do you mean by size of lumen and length of vessels? Okay. Good on that one? We don't have a lot left. These are all getting at control of blood pressure. And I'm going to work this the opposite. No, let's do it like this. Let me keep it like it was. Control of blood pressure. A similar question to control of heart rate. So in some ways it gets confusing. Where it's different here is that, yes, we have the baroreceptors and we have the chemoreceptors. We have a different cranial nerve here. So the glossopharyngeal nerve gets involved also. These are in the carotids and the aorta. What I did not put here is what exactly it does to control blood pressure. Okay, so yes, we have receptors, and that's where they are. What do they do when the receptors get activated? They send a message up to the cardiovascular center, and then a message gets sent back down to your blood vessels to get constricted. So the end game for this, vasoconstriction. Either you constrict them or you dilate them. So your body can constrict a lot of these arteries and arterioles, or they can have a vasodilation. Now, I didn't really put that here. But that's what it's doing. It's causing vasoconstriction. And then chemical, which also causes vasoconstriction. You have angiotensin 2, that causes vasoconstriction. You have aldosterone, that's going to cause you, and I didn't put aldosterone here, but aldosterone is another one. It keeps sodium, it holds back sodium. ADH is very similar to angiotensin 2 and aldosterone, right? Vasopressin, ADH, vasopressin, it's a vasoconstrictor. And it has you keep water. But honestly, peeing less, if you're thinking about something like a fix, like a quick fix for low blood pressure, making less urine is not a quick fix. That's a very slow thing, right? So the quick fix, constrict your blood vessels. Like when you're in shock, you're constricting blood vessels. I mean, and maybe making less sweat, right? But really you're constricting blood vessels and speeding heart rate. That's why the epinephrine and norepinephrine here. So you're going to speed your heart rate. That's going to raise blood pressure. And norepinephrine is going to make, it's going to affect contractility, stroke volume, right? So it's going to make it more forceful, the contractions. So a stronger heartbeat and faster heartbeat is going to raise blood pressure. You guys remember what this one does? I'll want you to say what it does. So I want you to know that this one's different from these others. You know, don't just list like I listed here. Try to explain, you know, what does ADH do? You know, just saying that it's a vasoconstrictor, that means a lot. Saying epinephrine is going to increase your heart rate. Okay, then you get what's going on. AMP is going to do the opposite. It's going to lower heart rate. It's going to lower, it's a vasodilator. So you just think, what does ADH do? AMP is going to do the opposite. It does the opposite almost in every way. So here's a confusing, like you have control of blood pressure, and then you have control for shock. It's the same. So nothing wrong with that. It's the same stuff. When you're controlling shock, shock is essentially low blood pressure. So when you control for shock, you're controlling for low blood pressure. So the answer are the same. So I'm going to probably ask you, yes I am, about shock. What are the 4 types of shock? Or, as I wrote here, what are 4 types of hypoperfusion? So I'd like you to just to know what, you know, hypovolemic, what does that mean? You know, and so that means it's low blood volume. That one I wrote out here. Cardiogenic. Don't put cardiogenic MI. I'm not even sure, like when you answer questions on a test, I don't know that you even know what MI means. Like, do you still know what cardiogenic means then? Well, yeah, I mean, it's simple. It means the heart's not functioning properly. But that, I mean, that's good enough. Just say that the heart's not working. Something's wrong with the heart. That's good. I just put MI heart attack to give you an example. Obstructive, there is an obstruction in the blood vessels. PE is just an example of one. But that doesn't actually explain what obstructive is, right? Obstructive is something's obstructing your blood vessel. And then I got vascular written out, inappropriate vasodilation. So it's there, low blood volume, the pump doesn't work, something's blocking the pump once it goes. All your, resistance has been dramatically decreased, right? Because the lumens increased. Or you just say inappropriate vasodilation. Those are 4 types. If you wanted to talk about sepsis instead or something like that or some other kind, it's fine. And then if I ask this question, I'm gonna make it like a 2-part question. What are the types of shock? And how can the body respond to shock? That question. And just the stuff that you know. The body's going to respond to shock by constricting blood vessels. So then you ask yourself, how does the body constrict blood vessels? Well, the brain can do it. The brain can send a signal right down to your blood vessels and constrict them. Okay, are there any chemicals that constrict blood vessels? Well, vasopressin, ADH, that constricts blood vessels. Angiotensin 2 constricts blood vessels. So, that's actually that's all I put here. That I always put renin and angiotensin. I mean, really, so they put that on like tests. Like I've seen that like on the HESI where they won't come straight out with the answer. The real answer is angiotensin 2, but instead they're putting renin angiotensin pathway. That's kind of why I'm doing it. I'm getting you used to it. But really what they mean by this is in particular angiotensin 2. So we have 1 question, 2, 3, 4, 5, 6, 7, 8, 9, 10, the 11th question, 12th question, and last 13th question. I asked 10 out of these 13. So if you know all these, I mean, you've got it. There's only 3 of these that you're going to study that I'm not going to ask. And then if you're a betting person, you're thinking, well, am I really going to not ask stuff on the blood vessels when I already gave you a quiz on the heart? So anyway, do you have any questions? Let me stop recording this. Are you guys even still here? You are. Stop sharing. Stop recording.